All right. Hello, everyone. Shall we get started? All right. Fabulous. Hello, hello, hello. Good morning. My name is Cindy Ames. I'm joined by my colleague Matt Gaskins, who is also speaking today. We are product managers at AWS, and we're excited to be with you to talk about our open source solutions for our Amazon dedicated cloud regions. Amazon dedicated cloud, if you haven't heard that term before, that is what we refer to our secret and top secret regions. So if I fall into it with saying ADC or Amazon dedicated cloud, that's what that means, our classified isolated regions. So before we dive into the solutions, I want to tell you a little bit more about us and our team. We support the AI/ML service team, which builds, expands, operates, and maintains all of the AI/ML services in our dedicated regions. And in addition to maintaining and operating these services, we also have an open source solutions software development program. And in this program, that's where Matt and I are focused. We are building open source solutions that address the very specific needs of our customers in these classified regions. So if you think of our typical AI/ML services on one end of the spectrum and bespoke professional service like engagements on the other, these solutions fill a gap right in the center. Now, we have 3 solutions in our portfolio, which we'll be discussing today. We have ML Space, Lisa, and Oversight ML. All 3 solutions, our customers benefit from some of the points that you see here on the screen. So all 3 are open source. Our roadmaps are customer driven, and we because we're open source, our customers are able to essentially own the code and modify and customize as necessary. We offer as well the ability to use our solutions within not only our classified regions, but they are also compatible with our GovCloud regions. So anything we're discussing today goes for GovCloud as well, and of course our commercial regions too. So also, as you're thinking about perhaps taking next steps with any of these 3 solutions, our professional services ProServe teams, also we partner with them, and they have support packages that you can pursue as well. Now, we think of the total cost of ownership of these 3 solutions with 3 different categories. The first is the software itself. Again, it's all open source. We're leveraging either the Apache 2.0 or MIT 0 licenses, permissive licenses. So there's no subscription or licensing fees associated with the software. Where costs do start to come into play are your cloud usage costs, depending upon your use cases and your workloads, which is that second category you see here on the slide. So this will be dependent upon what you're doing, and we're happy to work with you to provide some estimates if you're interested in seeing about what your workloads might look like in various regions. Now, the final category of costs that you do need to consider with any software, of course, are the DevOps costs associated. So if you have teams on site that are capable of deploying and of software and maintaining it, then that's perfect. If you have an SI partner that you're already contracted with, that's also you can roll that into your DevOps costs. And alternatively, if you wanted to contract with ProServe for any of these solutions as well, that's also an option. So definitely consider what your unique DevOps costs look like for your needs. So that's very high level overall sort of breakdown of how we think about costs with these 3 solutions. So diving into our first solution, ML Space, I'm starting here because at some point in your, I'll say, GenAI journey, you're going to be interested in building models or even fine-tuning LLMs. And you're going to need to be thinking about where you want to do that. And ML Space is one option that you have. Now, a number of years ago, to give you some background before we dive into the features, a number of years ago, our professional service ProServe teams were approached by multiple NatSec customers with the same challenge. Their data scientist teams and groups were not able to easily get up and running quickly with SageMaker due to restrictive privileged user policies. I'm sure you're all familiar with these, whether it's called that or not in your organization. This can accumulate to tens of hours for each individual user getting certified. And that is before they're able to have an individual AWS account and then start doing their work. So these customers wanted an alternative option. They wanted to have a web-based environment where teams could just access and just start working and not have to have their own individual AWS accounts. So our ProServe teams implemented some bespoke web apps, very successful. And as the service team, we were looking across all of our customers, and we realized this is a requirement not only across our other across our other NatSec customers, but also within our DoD customers and our FedCiv customers, from GovCloud all the way up secret and our top secret regions. So as the service team, we wanted to support and accelerate adoption of our services faster. So we productized that offering into what is ML Space today. So what is ML Space? It's an open source, accessible, web-based data science environment. Customers are activated and in the environment by an administrator, and they can immediately start working. Now, the GenAI tie-in here is that if you have LLMs, artifacts that you want to fine-tune, you can bring those artifacts to ML Space, work within ML Space collaboratively with your teams to get that done. All right. Jumping into some more highlights here about ML Space. So it was really important for us to make it quick to start in two different ways. The first is that it's fast to install. So once you have your prerequisite steps in order, you have your AWS account provisioned, you have access to it, you have the details of your identity provider ready to go. We have a whole list for you. As soon as you have all those prerequisite steps addressed, you deploy ML Space via CDK, one command, and it's about a 30 to 60 minute installation time. So quick to start in that way. The second way it's quick to start is that as soon as administrators start activating users in the environment, as soon as they log in, project owners can start adding those users to existing projects, or data scientists can start creating their own projects and adding collaborators within their projects. So it's quick to start, and you've heard me say the term project. You'll see here on the screen a screenshot of ML Space. This is an example project called Geospatial, and this is where teams theoretically could be coming to train geospatial models for computer vision, let's say. And you'll see here on the left pane navigation, all of those SageMaker resources that then become available once you create a project. Very similar to using SageMaker through the console by design. So customers can, I should say data scientists or data analysts can come in and create resources through our UI forms, just like they could if they were working in the console. Alternatively, they can spin up SageMaker notebook instances and work within Jupyter, just like they could within the console, to do their work there instead. Any resources that they're creating, either through the ML Space UI or within Jupyter, are then available for their project teammates to access and view via the UI as well. So if you created training jobs, your coworkers could then clone those training jobs for their purposes within that project. There are a couple different roles within ML Space. We have administrators. They have oversight and insight into everything going on within the platform. So they can stop long-running resources if they choose. They can also set the high-level configurations of the environment. So they can restrict the available instances that are possible for selection or usage by any users within the application, which helps manage costs and control costs. They also have the ability to run reports and see the status of any kind of resource across every project. Now, the second major role are project owners. Anyone by default can create a project within ML Space and then add ML Space application groups or individual users to a project. As a project owner, you can set default termination schedules for a number of different resource types, which also help control costs. So you can, for instance, set the daily suspension time of notebook instances in specific projects so that if your users don't spin down those instances, you're not incurring those costs overnight. So these are some added capabilities that we added into ML Space because we know that our customers are very cost conscious and attentive to that. Now, I'll also add that project owners also have the ability to manually suspend or kill long-running resources as well. So there's additional oversight there. Now, the GenAI tie-in again here is that if you had LLMs that you were fine-tuning, you'd bring those artifacts to your administrator who would place them into ECR and then provide that path to users who would then be able to reference it and fine-tune those models within ML Space. Diving into the architecture here, ML Space by design is serverless to keep those application hosting costs very low. It's installed again into a single AWS account. You configure it with your identity provider, and you are essentially using, there's two main components at play here. You have the front end application, React application, in the Cloudscape framework, which makes it accessible for our users within the tool in the application itself. And then you have the backend Lambda functions that are calling the SageMaker service behind the scenes. This is all in our GitHub as well, and we'll be providing that link at the end. So no worries on jotting everything down. We have it well documented too. All right. So moving on to our next solution, what do you do after you have trained your models? You want to run inference on them. In the case of LLMs, we have another solution called LISA. And LISA stands for LLM Inference Solution for the Amazon Dedicated Cloud. So two acronyms to create that third superior acronym of LISA. And what we have here is a solution that we created in direct response to our customers' needs. So as GenAI interest and adoption has exploded, our customers in our classified regions were immediately excited about what they could do today. And in order to support the experimentation, adoption, and usage of GenAI and those use cases in these regions, we wanted to address the undifferentiated heavy lifting of hosting and inference so that our customers did not have to architect that over and over and over again. We want to supply that to you so you can get up and running quickly. So with LISA, it's infrastructure as code. It's deployed into a single AWS account as well. And you can bring models for self-hosting within LISA, which I'll dive into a little bit more in a moment. In regions where Bedrock is available, LISA has additional capabilities that you can use to address your use cases. And of course, in regions where LISA or Bedrock is not available, you can use LISA to self-host those LLMs and your workloads. So think of LISA as accelerating, your adoption of GenAI today. We're offering, again, that foundational, scalable, repeatable infrastructure so that customers can focus on GenAI experimentation and adoption itself, and then building on top of that infrastructure. Diving a little bit deeper here. Again, LISA's infrastructure is code deployed via CDK, just like ML Space. You have the option of self-hosting models via Amazon ECS with LISA, and we support text generation models and embedding models. We also are compatible with OpenAI's API spec and Light LLM, and this buys us a few things. The first is that this means that you can also configure LISA with external model providers that are also compatible. So for example, if Bedrock is available in a region, you can configure LISA to access Bedrock models. You can also configure it to access SageMaker Jumpstart models, or any other compatible model provider that Light LLM supports. And so this moves Lisa from self-hosting into the model orchestration layer, or capability. And as your GenAI journey evolves, you're likely going to be balancing and using many LLMs and various models for different use cases. And you'll need to consider that orchestration later for how you're handling those interactions and those calls with all of those external providers. So with Light LLM through Lisa, you're able to centralize and standardize all of those calls so you're not handling all of that yourself. Now, additionally, we are providing APIs, which I'll talk about in a moment, as well as an example, Chat UI that you see here on the screen. And this Chat UI allows you to use and leverage additional features that we have with Lisa as well. That's inclusive of prompting models, of course. We have the ability to load files into configured vector stores for RAG usage, which I'll be talking about in a moment. We also allow you to modify your prompts, modify your model arguments, and view metadata for each prompt and response that you're having with the LLM. Okay, so the next thing that our OpenAI API spec support gets us is the ability to easily configure with other compliant tooling. So one example I have here is we have, and there's a screenshot here, we've configured Lisa with VS Code's IDE using the Continue plugin. So what you see here is a developer's development environment. And on the left side, they have written a block of code. It's like hello world 7 different times. And they've highlighted that code. And they have used the Continue plugin, which is used for code generation. And they're using Lisa as their model provider. So at the bottom here, you see that they've selected the Mistral model that Lisa is hosting. And then in their IDE, they're asking questions of the LLM. So they're saying, what is this block of code doing? And then, how do I optimize it? And the LLM is giving them examples and responses. And that LLM is hosted through Lisa. So you can configure Lisa very easily with any other tooling that is also compatible. Diving a little bit deeper into some Lisa, major components of Lisa. We have 4 that we've divided up here. The first 3 are on this slide. Lisa Serve is that foundational core component of Lisa. It is what you're using. It's not optional. So if you're using Lisa, you're using Lisa Serve, and you can use Lisa Serve again to self-host models or to integrate with external model providers, like I've already spoken of. We also have model management APIs, which are going to be important for when you are adding models, removing models, updating models as your use cases changes and your needs change. So you can leverage those APIs as well. Now you can configure Lisa with mission tooling, with other compatible tooling like I showed you in this last example, and you can leverage our APIs for that. Now, we also have a second major component here is the Lisa Chat API. And the Chat API is handling all of the history, the chat conversation history in every session, as well as the continuity of conversation. This is optional, you don't have to use it, but it really helps with the user experience. The third major component that you already saw is that example Chat UI that you can use. As well. You can have your users, of course, interacting with the LLM directly in our UI. You can also, your administrators can also leverage our model management UI. So instead of using the model management API, you can manage those models through our model management user interface. The fourth major component of Lisa is retrieval augmented generation, RAG. And this is going to be really useful as you are looking for your models to provide more specific responses to your users. fine-tuning models, it can be very expensive, and your proprietary organizational information might be changing often, and you don't want to have to be training these models with updated information. Or perhaps you have mission-critical data that updates throughout the day, or is updated daily. So an alternative here is to configure Lisa with a vector store and load that data into the vector store, and then your LLMs are incorporating that proprietary information or that mission data in the responses back to you without having to spend the money and the time fine-tuning them. So we have pre-configured Lisa for use with Amazon OpenSearch as well as PG Vector through RDS. You can use both or either. You can also use them as examples to configure with other vector stores as well. Through our chat UI, I don't know if I mentioned this, you can upload files directly into the configured vector store, and the embedding model is handling the chunking and the vectorization of that data for you directly into that vector store. So it's a very high level breakdown, but this will be really helpful and powerful and something you definitely should check out depending on your needs. Now, I also have an architecture diagram here. You are welcome to view our GitHub. We dive into different areas of the solution as well, and we have it well documented. But for the purposes of today, I wanted to show you Lisa Serve architecture, which is that foundational core component of Lisa. And again, we are using specifically services that are available in our ADC regions. And all of our services are also FedRAMP High compliant that we're using. So for our GovCloud customers, I know that's very important too. Now, on the left side here, you're seeing all these components are designed here for scale with the model hosting fronted by application load balancers. So Lisa, like I mentioned, is offering different options for model hosting. That first is self-hosting through Amazon ECS. And that's, again, two different model types, the text generation models and the embedding models, which is important for RAG. And through ECS, we are supporting Hugging Face's text generation, inference container or TEI container as well as VLM container. So any model that you're bringing to Lisa would need to be compatible and is likely compatible with one of those. So from there, you would be selecting for each model the instance type that it is configured with, which is represented here, and then you'd be storing those model artifacts in S3. Alternatively, if you are configuring Lisa with external model provider, we have an example here in the architecture of down here in the bottom right of configuring with Bedrock models. So the service in this case, or this other external model provider, would be hosting the model for you, and you would just be interacting with that service, which is that second option. So now I am going to hand off to my colleague Matt, who's going to talk about a different flavor of inference with models. He's going to dive into our third solution in our portfolio, Oversight ML.
Hey everybody, I'm Matt. We're almost to lunch. We just had it at lunch. By show of hands, who deals with imagery, geospatial analysis, or pictures? We just have a few. I get to nerd out on geospatial imagery analysis. Amazon saw a need that power, space, and compute is not always easy. It doesn't matter if you're government, it doesn't matter if you're commercial. You have to have a data center. You probably have to have some accreditation. You probably have to cool it. You need to connect a fiber wire that's going to get the data for AI in throughput. And you have to buy these big pieces of equipment that often cost a lot of money, hundreds of thousands. You have to get a system administrator who can then configure it. You have to have a thing that connects to it. There's a lot. Power, space, and cooling is just a portion of it. And so with Oversight ML, we launched this to use what Amazon's really good at. AWS has infrastructure. We have a lot of computers. We have data centers. And that compute is pretty easy to get to because we have all these services like SageMaker. We have Fargate. We have EC2, ECS, lots of acronyms. And the world has a lot of imagery. there's a lot of pictures. There's a lot of sensors that fly over the Earth. We have LEO, low Earth orbit, MEO, middle Earth orbit, high Earth orbit. There's these sensors flying over. They take lots of pictures, or they do these things with radar. And analysts want to look at those pictures, but not really. I mean, they're sitting there with Mountain Dew and Cheetos, and they're just like, yep, there's an airplane. Yep, there's a crop that has corn in it. And so we have over 15 customers using this open source project, like Cindy said, and it's called Oversight ML. We have government, we have top secret, secret, commercial customers. Some people are looking at rows of corn, and with hyperspectral imagery, hexadecimal code can tell you whether or not it was watered well enough, or maybe a pesticide has done something to it. You can find out if a lot of planes are in an area. You can find out if a parking lot is full. And this is called object detection. Now, in order to make this detection work, there's a lot of prerequisites that happen. And so Amazon not only took our great infrastructure of compute, power, space, and cooling, and we put some back-end pieces on this. Now, object detection can work for anything, but specifically I care about large-scale imagery. Now, lots of people take pictures of people's faces and then can do object detection and recognition to tell you it's a human face. When you log into your iPhone or your Google phone or Pixel, it does some sort of recognition of that Face ID. Now, this is different. This is a typical image is, in this world, like 240K by 240K, vice an image that could be, 1024 by 1024. And so in computer vision, it best runs at 1024 by 1024. So you have to take apart a very large imagery. It could be of a whole country. It could be of a whole airfield. You want to find all the roads in a neighborhood to figure out if a project's been done. You want to find out about infrastructure and how many emergency supports happen. And so this is the term object detection, feature scene extraction. And that's what we do. This comes, again, open source with Oversight ML. Now, I want to nerd out a little bit. This chipping of these very large, 240K by 240K images have to be tiled and chipped, because standard computer vision models don't work well with 240K by 240K. It takes a lot of time, it takes a lot of money, and it's not efficient, it costs you a lot. And so when you break it out into small pieces using, say, a YOLO-X or a ResNet or a Detectron model in AI, what you find is that in step one, you'll see you chip it, you keep the metadata, and then you process it against your computer vision container. Now, there are some prerequisites to this. In order to do the analysis, we provide that compute, we provide that inference, and we provide that back-end infrastructure for the object detection. So once you've supplied your model, and once you've supplied your imagery, the rest is taken care of. So in step two, the computer vision container takes your model that you've provided the system, it looks at that imagery, and it says, there's a thing there. And step three, what you have is features that come with it. Elevation could be with it, you have a lat, you have a long latitude and longitude, and then finally in step four, you have several ways to identify an object. You have polygons, bounding boxes, you have a point, you care about that thing. And your model has already provided those weights and inputs. What I love about this, and I just want to say, I've been in the military 22 years. I've worked for large companies. I'm not just an Amazonian. I've worked for small companies. I've been a warfighter and a user of imagery analysis, and I've also been somebody who's had to deploy it, and now I'm somebody who gets to build it for customers. And so I'm not in sales. I just get to say what we build. It's actually really fun and super cool. I tell my engineers to do something that is our leadership principle, be customer obsessed. What does the customer care about? What do they need? How is it deployable? And how will it be effective for everyone? It has to be effective for everyone. It's open source. Now, it's not going to be 100% effective. You're going to have to tailor it. Cindy talked about having 3 parts to cost. One of them is you're going to have to tailor it to your environment. But what we did here is that we made sure that the taxonomy of computer vision worked with open standards. So you have things like stack catalogs, you have DoD compliance, ATO, you have FedRAMP, you have NIST, you have, it has to work with GeoJSON, and it has to work with NIDIS that are images, and it has to work with SAR, synthetic aperture radar, and EO. And we did that. We made sure it worked with everyone who's come to us and said we want to do geospatial analysis and inference. And so, on the next slide, a few key features that I love about it. STAC, which is a spatial temporal asset catalog, space and time, tied to a piece of data, which is a tile, a chip, a pre or post-process imagery, lots of words. What I'm saying is that it's an open standard that we made sure it worked with, so that if you take it and consume it in your own system, we know it works with other things. We tested against film drop for a user interface. We tested it across Leaflet. We tested it across the Open Geospatial Consortium to make sure that it worked with the standards of the geospatial community. And we did that so that you don't have to deal with the burden of taking an open source piece of product and trying to figure out how to make it work. We've done a lot of that in the background. Now there's a little bit more nerdiness to this. The Earth is not flat. It happens to be round. But the image you see on your screen happens to be flat. And ones and zeros are neither of those things. And so what has to happen is when a sensor takes a picture, we'll just say of a mountain in Afghanistan, off nadir, meaning to the side, that image is going to be warped already. And now it needs to go on a round map of some sort and then be rewarped with latitude, longitude, and elevation and look decently normal to you with the point that you care about, so that you can make some sort of decision or adjudication about the piece of information you care about. This is called, and actually I love this argument, some call it georeferencing, some call it orthorectification, some call it georectification. Right now we'll just call it georeferencing. Your latitude, your longitude, the image that you took, and the map that you have, which are two different things, are all stitched together to look nice so that you can make a decision about it. And so the nerdy term for this is rational polynomials. That's what the smart people do, and they call it math, and they don't care what the image looks like. They just stitch it together. But we've done that. And so essentially you can consume this code from GitHub. It exists there. You don't even need me. You can go to github.com for ML space, Lisa, oversight ML, and download it. And you can steal pieces of the code. It's not stealing, I mean, we put it out there. You can take the code, you can take snippets, but I hope you don't just do that. We're product managers. We're not in sales. We just make products that we want customers to use that solve community problems. Cindy didn't mention this, but we both served almost our entire careers supporting the government. We've served our careers helping out customers. The term customer obsession is very important to us. And we care about making sure that it works for you. So as you do things in your AI journey, as you start working with GenAI, as you start working with, hopefully, object detection, we want to hear your feedback. If it's no good, we want to know about it. We can support another product and solution and nerd out on something. But we hope that you download it. We hope you try it out. We hope that you use it to solve your mission needs and your organizational needs. We've tied a lot of customer data. There's between the products that we have over 50 customers that are using this that are commercial and government. And so you get a lot of benefits of a lot of people contributing to code that can be great. So we'd love to hear your feedback. Please download and use this stuff. And please reach out to the Amazonians that are here if you have any questions about it. And with that, that concludes our presentation. Thank you. Any questions, by the way? We can nerd it out.
What would the process look like to get an alternative injector score?
Garmin Fenix 8. Just came out October 1st. I love it. It's super cool. And it has maps on it.
Any other questions?
So, Matt, thank you for the presentation. Two questions. One, we did know a little outlet, and then also, since we're talking about open source, full integration with other ways, all the whole spectrum of the ones there, I heard your name, and I think you glazed over it. Do you have a minute to kind of explore that out?
We are supporting honey-based CGI and CGI containers, as well as DLLM, and that's for LLM and embedding models. The architecture diagram.
It's the Lisa serve.
Yeah.
Go ahead.
No problem. So each model for self-hosting, did I miss it? It's coming up here. Each model for self-hosting has its own here we go. Let me make this a little bit bigger for myself. Has its own ECS cluster, and so the necessary container would be selected during configuration of the model. And you could do that. You select the container within either the API or the model management UI. You would have to make sure that you have those containers in region. Depending on the region that you're working in, we can suggest where you might be able to find those containers, or you'd have to move them up yourself. So that is a consideration as well that you should that you'd have to think about too. I think the next best way to dive more into this is we have more detailed specific architecture diagrams in GitHub, and we dive into this a little bit deeper, so it's well documented. And so I think that would be the next step to take, would be checking that out, and then happy to meet and talk more too.
We'll be here. Any other questions? Like I said, we'll be here. I think one of my first topics was lunch, so we'll be around.